Running autonomous coding loops on models like Claude Opus 4.6 can drain a development budget. At $15 per million output tokens, a single day of agentic engineering tasks can generate a massive invoice. Recently, 5 new Chinese AI models launched with a clear objective: to match the performance of these expensive incumbents at a fraction of the cost. The internet is full of claims that Kimi, GLM, MiMo, DeepSeek, and MiniMax are outperforming the industry leaders on every major benchmark. We have to determine if these performance scores reflect actual technical breakthroughs or if we're just seeing the results of sophisticated benchmark gaming. Developers need more affordable compute, but building an entire engineering pipeline on hype-driven tools is a gamble that could result in broken code bases and critical project delays. The first audit target is the widespread claim that these models are universally more capable than GPT-5 and Claude Opus. This chart shows aggregate AI capability based on NIST data. The US baseline remains consistently higher, showing the new models are 8 months behind the frontier. But the data breaks apart in specialized niches, where these models legitimately match or outperform the US baseline. Kimi K2.6 stands out in visual-to-code tasks. It takes a raw UI screenshot and generates production-ready front-end code with a level of aesthetic precision that generalist models often miss. GLM 5.1 focuses on backend autonomy. It executes continuous planning, coding, and debugging loops for up to 8 straight hours without needing a human to course-correct. MiniMax M2.7 is built on a self-evolving paradigm. It autonomously developed and optimized its own reinforcement learning research workflow, handling nearly half of its own training iteration cycles. The data suggests that there is no single God model here. These are hyper-specialized tools built to dominate specific developer tasks. Because these models are priced at fractions of a cent, many assume they must be small, low-tier systems with limited depth. This diagram shows the mixture of experts' architecture. DeepSeek V4-Pro has 1.6 trillion parameters, but only activates a tiny fraction of specialists per request. By running just 49 billion parameters per token, it provides massive depth with the compute overhead of a small model. Hardware economics also play a role. To avoid US export restrictions on NVIDIA chips, Zhipu AI trained its models entirely on domestic Huawei Ascend hardware, restructuring the cost of training from the ground up. Beyond tech, there's a clear market strategy at work. Labs like DeepSeek are intentionally compressing profit margins to capture ecosystem share from US incumbents. These ultra-low rates are the result of efficient mixture of experts' architectures, combined with a subsidized push for global market share. The final audit target is the concern that adopting these models requires migrating to foreign ecosystems or building complex new infrastructure. These models are actually designed to be plug-and-play within existing Western developer environments. This flowchart shows how API gateways like OpenRouter translate third-party models into the standard Anthropic messages format. Because the output is standardized, these models connect to Claude Code and VS Code instantly. You only need to change a single environment variable to reroute your requests. Developers can keep their existing workflows and IDE settings. Swapping an API key is the only step required to unlock these cost reductions. The US closed frontier still holds a clear advantage in complex, multi-constraint reasoning and integrated multimodal workflows like video and audio processing. There are also institutional risks, including a lack of enterprise compliance documentation and the mature service-level agreements that many corporations require. However, the period of using one massive, expensive model for every single coding task is over. The current best practice is to match the model to the task. Use MiMo for token-efficient code reviews and DeepSeek for general tasks, while reserving your high-cost models for only the most difficult reasoning problems. AI coding compute has become a commodity. In this environment, ignoring these ultra-cheap alternatives is simply a cost.